Hi there, let me show you in this video 3 ways that you can make a multicolor 3D print with only one extruder without you needing any fancy printer or an automatic filament changer. I'm going to use in this tutorial Tinkercad and Prusa Slicer to show you how I have made these 3 examples over here. The first and the simplest method is designing your model to have different layer heights for every color. Let's open Tinkercad, place a cube and give it the following measurements: length of 40, width of 60 and the height of 1. All measurements are in millimeters. After that, let's take the text and place it over the cube. I will write my channel name with 3 text items and I will place all of them inside the cube. You can try it out with different items or with text as you wish. For projects, I will give a height of 2. For width, I will give a height of 3, and for Alex, I will give a height of 4. Now let's export this thing and select in the export dialog everything in the design. I will open it in the slicer software, select the layer height to 0.1 mm and I will modify the perimeters to 1. Now we know that every part has 1 mm more as the previous one. So the cube has 1 mm, the word projects has 2 mm and so on. We want now to use the slider on the left and go to 1.1 mm height and then press on the plus button next to the slider to add the color change command. And now, as you can see, all the words have different color from the cube. Following the same idea, we want to add the color change also to the other words. So we will add the color change on height 2.1 mm and 3.1 mm. And now you can see that all the words in the cube have different color. Slice it again and let's print it. So this is how the multicolor 3D print looks. For the second method, we can see how we can add a color change into the same layer. But for that, we have to go back to Tinkercad and make some changes. So the first thing we want to do is to select the 3 text items, in my case, make them a whole and give them a height of 0.4. You can give them a bigger height, but it might be possible that you're not going to be able to print them with the third method. Also, you don't want to go over 0.8 mm height because you're gonna need at least one top layer to be able to fuse them all. After that, we want to go to the pattern view and select each of the text items and mirror them so when we remove the print from the bed, the text has the right orientation. And then export the print again with the selection of everything in this design. Give it a name and save it, and then return to the design and make the 3 text items solid again. We want to export all 3 of them individually, that means selecting one text item, press export and select just this design. I will open now the cube with the text cut out in the slicer, and as you can see, if I slice it and go to the first 3 layers, you can see that there is a hole exactly in the place where the text should be. Go to printer settings, general, and where it says extruders, I will modify to the value 4, meaning 1 extruder for every 3 of the text item STLs and 1 for the cube. When you go back to the plate, you will see that under the filament, you have now, instead of 1 instance, 4 instances. We will add now the other 3 STLs, and we're going to do that by right-clicking on the STL from the cube, add new part, and select all the other ones. You can see that they have been positioned exactly in the cutouts from the cube, and next to each STL on the right side you can see a default filament already selected. That means that you have 4 extruders and every one of them can use another color. You can choose for every filament another color by left-clicking the color and give every STL a different color to be used by the extruder. And in the end it will look something like this. Another setting that you can do is going to the print settings and modify the width of the wipe towel. This is going to help with the transitions between colors so no color residue is left. Another trick that you can use is modifying the layer height and give a different layer height to speed up the print. For example, I have added here that between 0.6 mm and 2 mm I will use a layer height of 0.2 mm. And one of the most important settings that you want to make is go back to printer settings and go to custom G-code. There you will need to copy the contents from color change G-code into tool change G-code. Slice it up and we can now print it out. And here are the results from it. Okay, now for the third variant we're going to need Notepad++ or a text editor of your choice. The idea is here that we're gonna use the text editor to make our own G-code file from every STL part. This will allow us to print one color all the way up without us needing to make filament changes at every layer. Let me show you what I mean with this G-code file that we're going to make. As you can see on the right side, the layers go from 0.2 to 0.4 and then again to 0.2 to 0.4 and so on until the last part, that is the cube. We are going to go back to the slicer and revert the extruder value to 1. We are going to import the cube with the cutout and this time only add the project STLs to the cube so that it goes into the right position. If you do this without the cube that we will use as a reference, then all the STLs will be placed in the middle of the plate. After that you want to delete the cube, but don't delete the main model from the tree, delete the child of it like I do here. I already made some predefined configurations for this method and I'm going to explain them to you. The first configuration that I made is called first color. Every G-code generated by Prusa Slicer has a beginning and an end to it where some commands happen. If you'd like to know more details about every G-code command, go and check out Prusa documentation into the link below. For now you need to know that the first color config means only that the beginning of the G-code generation is kept and the end is erased. How we do that is by going to printer settings, custom G-code and erase everything in the end G-code section. After that you can add the lines that I have in the same section. The first line is going to move the printhead on position X220, Y0, that is the right lower corner of the heat bed, and the M600 command is used to request a filament change. Also I have added that command that starts with the semicolon, next color PVA marker. I forgot when I made this setting, so try adding the same comment under G1 command. This is going to help us to find the end and the beginning of the G-code that we want to keep. So now that we have done this, let's slice it and export it. For the next STLs, Width and Alex, we are going to do the same as we did with the project STL. But since they are, let's say, in between prints, I have saved my configuration as next color. That means that we will erase everything in the section start G-code and add a comment as before to use as a marker, but leave the end G-code the same as it is in the first color configuration. For the cube, since it is the last model that we want to print, I have called my config last color, and this one has no start G-code section except for a comment that we will use as a marker, but has the initial end G-code section. Now we will take the project's generated G-code and make a copy from it since it contains that start G-code that we need. Search for the comment that you have made and erase everything after the last comment. I didn't have a comment here, so for me I will erase everything after the G1 command. Now we want to copy the other two G-codes, so we will need to copy from the first comment from the start section until the last comment of the end section and place it under the comment from the copied project's G-code. Last we want to copy from the cube G-code from the beginning marker until the end of the file and again place it under the last comment from the previous color. Now we should have the exact same G-code like I showed you in the beginning. This method, as you can see, takes a lot more time to prepare the G-code, but in comparison to the second method, you don't have to do lots of filament changes. In the end, I think you can use all of these three methods, but in different applications, as every one of them has its plus and its minus. Of course, an automatic filament changer like the MMU2 for Prusa or the AMS system from Bamboo Lab are much more quicker and give you more possibilities. But everything depends on the application where you use it. Like I have used these three methods that I have showed you to design these Disney lamps over here. That being said, let me know what you guys think about these three methods. If you found it useful, let me know it down in the comments, and I hopefully see you guys into the next one.